Okay, let's start. Today we'll be seeing the tree data structure, and for first 5 minutes, I'll give the stage to Shivam. He will explain the applications of tree data structure. Are you ready, Messi?
Yeah, Vallabh.
Yeah, you can. This the screen is yours. Yeah. Messi, you're on mute.
Yeah. So, uh, yeah. So can I start?
Yes, 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 yes.
Yeah. So I'll just speak only.
Okay, okay.
Yeah. So trees is one of the data structures which is used for, for various applications in machine learning, like making a decision tree, or be it of saving a files in hierarchy wise and all. Uh, there are various types of trees which are used, like binary tree, binary search trees, and yeah. So a tree can be defined in a way that it has a node and edges, and it starts from top to bottom, and uh, it starts from a root node. A root node is the top hierarchy. Uh, And yeah, I think this is the basic introduction I can give for trees for now.
Okay, okay. Thank you, Messi. Okay, Messi has explained what a tree is, but let's see. I think it is already clear, but let's make it even more clear. So this is one sample of a tree. The tree will have one root. I think my screen is visible to everyone. Please let me know if it's not. Okay, I assume it's visible. Nobody has told anything.
whiteboard தானே உள்ள?
Whiteboard இல்லை. I've shared my screen.
Okay. Yeah.
Oh, okay. Just a second. No, no, no. 1 second. I'll reshare. Yeah. Sorry. How about now? Are you able to see my screen? I have opened a Chrome browser.
சொல்லலாம்.
Yeah. So the tree usually has a root node. Here A is the root node. They say it's level 0, and it has multiple number of children. We saw in the linked list last time that each and every node will have one address pointing to the next node. The main difference of a tree and a linked list is a tree can have multiple children. There is a concept called binary tree where it will only have two children, and there are generally trees can have another tree as their children. So the for in this example, if you see B and C are children for A, and D and E are children for B, and this Dij, this is called a subtree. The whole thing is called a tree, and a parent node and a child node together at any level, they are called a subtrees. That's it. tree is that simple. The main applications are they're used in our file browser, which is a very good example of a tree. And for the game that we are going to develop today, we are going to have a what to say, a biological tree, where we will be able to demonstrate difference between aquatic, amphibious and water animals. We will put them under a tree, so that when a picture is shown, you should be able to say whether they it is a land animal or a aquatic amphibious animal or a aquatic animal. You basically, you will be going traversing through the tree and saying yes or no to the options. Is that clear? So everyone will be developing this game individually, different parts of the game. We will see if we will be able to complete it this class, or we'll have it completed in the next classes. For now, we will only be focusing on the tree part. Okay, who's going to do the tree creation part? The creation part alone we'll all be doing it together. After that, we'll do things separately. We'll pick up separate things. We want to update, we want to read, and we want to delete. All these operations of the tree will be done separately. The creation alone we'll do together. Okay, who is volunteering to do the creation part?
I'll do.
Okay, you clone the Git repository to your local computer and share your screen.
Well, I'm sorry about the delay. I was outside, so I just joined. I'm driving.
Okay, okay. Drive safe, pa.
Yeah, I'll be a passive listener. Yeah.
Sorry, guys, just give me 1 minute. I need to get my charger for my laptop.
No problem. Balamurugan, is there any possibility that you can join from a computer?
என்ன லேப்டாப் எடுத்தீங்க பாலமுருகன்
வந்துட்டாரு.
Join
He's
பண்ணிட்டேன்
joined.
வந்துட்டாரு
Yeah.
ஓகே
Thanks, Balamurugan, because you will also be coding today.
இல்ல நெட்வொர்க் ரொம்ப
Interactive.
ஸ்லோவா இருந்துச்சு.
Okay, okay.
இல்ல பக்கத்துல வச்சுங்க லேப்டாப் பக்கத்துல வச்சுங்க மொபைல்ல ஜாயின் பண்ணிட்டு லேப்டாப் பக்கத்துல வச்சுங்க கோட் பண்ணுங்க ஹேண்ட்ஸ் ஆனா இருந்தா நல்லா இருக்கும்
So, has everyone cloned the repository into your system? You should be able to see this game running.
No.
some dependency எல்லாம் அதுக்கு இருக்குன்னு நினைக்கிறேன்
Just some pictures. I'll just share that folder separately.
ப்ரோக்ராம் ரன் பண்ணாலும் இட் இஸ் ஆஸ்கிங் ஃபார் சம்
Yeah, it
மிஸ்ஸிங்
needs
லைப்ரரிஸ்.
a folder called assets. I'll try to put it in our Discord folder. No, it doesn't accept. Okay.
அது கிட்லேயே போட்டிருக்கேன்.
Okay, I'll try to put it in Git.
வல்லப் அந்த லிங்க் மட்டும் அனுப்பேன்.
Okay.
Just பண்ணிட்டேன். வல்லப் லிங்க் டிஸ்கார்ட்
I've sent it
Discordல
in
போட்டிருக்கானே.
Discord. Yes.
I don't see any messages actually.
Okay, just I'll send it in WhatsApp.
No, I got it now.
Okay.
அம்மா
என்னம்மா?
என்ன பண்ணு? நான் இதை ஓபன் பண்ணிட்டேன்.
இங்க வந்து கேளு நீ. இங்க வா, இங்க வந்து கேளு. Vidya, is everything all right?
No, actually, it's giving some error.
No, that's fine.
Just
That's fine.
trying. Now I have.
You can just share your screen. We'll start working on the tree data structure. The py game is not so important at this part.
Okay.
GitHub லிங்க் ஓப்பன் பண்ணிட்டேன். நீ மியூட் பண்ணிட்ட. இது ஓப்பன் இங்கே போனேன் லிங்க்கு. ஓகே, இது இருக்கு.
அது கிட் க்ளோன் பண்ணணும். அது இப்போதைக்கு இம்பார்ட்டன்ட் இல்லை. நீ இது கோர்ஸ்
அப்போ நான் இது எப்படி பார்க்குறது?
அது இது இப்போதைக்கு எதுவுமே பண்ண தேவையில்லை. இதை ஃபாலோ பண்ணால் போதும். Yes, share your screen.
I am. You should be able to see it now.
It's echo அடிக்குது.
Do you see my screen or not?
Yes. VS Code. Yeah, we'll start. We are not able to see the VS Code. We are just seeing your browser.
I shared actually the window. Wait.
You can just share the entire screen and you can
Yes,
minimize.
that's what I did.
Okay. Yeah. So you can create a new Python file in the same repository. Yeah. That's a folder.
Oh, sorry.
Yeah, why a notebook? We'll just go with a normal Python file.
Not the script. Hmm?
It's just py.py.
Fine. No, I thought it will be easy to.
Okay, test it now and then. Is it?
Just,
Yeah. Okay. So
that's fine. We have it.
yeah, we will be needing a class called tree.
Okay.
Yeah, you can just hit tab. Now we can fill in the child and other details inside. Gopi, is this approach okay?
ஃபர்ஸ்ட் நம்ம ட்ரீக்கு என்னென்ன வேணும் அந்த மாதிரி ஒரு ஐடியா இருக்கா எல்லாருக்கும் ட்ரீனா என்னன்ட்டு அதை நம்ம கேட்கவே இல்லை நம்ம பாட்டு ஸ்ட்ரைட்டாக கோடிங் இறங்கிடும் ஃபார் எக்ஸாம்பிள் இஃப் we want to keep everybody in the same place, right? I think we are going little faster. We are not sure whether everybody know about these things.
Okay.
If we take a tree, what are the features or properties it should have? So how to for a tree there should be a node, right? So what is that node? What are the child node? What are the root nodes? Those things are not looks like not explained. I'm not sure whether everybody is aware of that or not.
Okay, we'll just traverse at every node here. We'll ask them, guys. Come
Yeah,
on.
that would be better, right?
Yeah.
No, Vallabh, before even we start, because it could sound complicated if you do not understand the concepts clearly
Yeah.
or the definition.
Agreed.
Because it
So
yeah. So
uh, as of now, what is your understanding of tree? Starting from who is Balamurugan is our first guy. Yeah, Balamurugan. Can you explain tree just for the knowledge that you gained from this class? Or did you understand or something? Anything?
It's a data structure
Okay.
mainly for mainly data structure which is mostly to denote, like, it has several different kind of nodes. From one node we direct to several other nodes, from parent node to children node.
Okay.
Basically, your idea is like there will be a parent and a child relation. For every node, there will be parent and child relation, right? That's what you are trying to say, right?
First of all, I would ask a question because I did not attend the last class. Maybe I don't know if it's right to ask.
Yeah, sure.
I know, okay, while searching or sorting the data in the data segment or heap or stack, we need a way to sort and order it and organize the data. So that is where this tree coming from, right?
Better
Sorting,
organizing. Yes.
searching, organizing the data in an order where everybody can, it's like a standard. The tree is like a standard where we follow the standard and we have some rules in it. That's it, right?
Yeah, right.
Yeah.
So basically, if we take a tree, so Balamurugan said that there will be a relation, like parent and child will be there. That is one point we can take. Anybody else? Any other points related to trees?
Yes, so I
Anything
would like
like
to
how
add
it is
something.
connected?
So if we just, I'm just putting it in simple words, how I understand. So if we think of a tree just outside the technical part, you know what are the things there will be, right? So you have you have trees. They have leaves, they have branches, they have roots. So these are some common things that comes to our mind when you say about a tree, right? So similar thing, we are trying to use it in the technical world also. So when you say a tree data structure, it has a root, and then it has branches, and then it has nodes. So the nodes are, we can call them then leaves. So basically, when you say a tree, then the tree cannot exist without a root, right? So not in data structures, but in general, how we know trees. So the root is considered as the parent. Then you have then children. They are then the leaves. This is only for my understanding how I remember that. It is easy for me to remember this way, so I'm just telling it also in the same manner. So again, one tree structure can have multiple subtrees. So we know that one tree can consist of a root, and then the nodes. For my remembrance purpose, then I connect it to leaves. So the roots and the leaves are part of the tree. Then you can have when you have a big tree, then there can be multiple leaves and branches. So that's how you can say the very first screen Vallabh shared. You had a parent node, and then you have subtrees, and then you had
Right.
branches. Branches are something that connects the roots with the nodes. So basically,
Okay.
the root with the leaves.
Yeah. So you shared a lot of information. So let's take it one by one. Okay. So I shared my screen, and you see it.
Yeah.
Okay. So now we hear a lot of things like
Now it's stopped. Now I don't see it.
Gopi, can you give a basic example of a tree? I know in routing algorithms, there are lots of routing protocols, layer 2, layer 3. We say with a name called tree, like spanning tree. Huh? Oh, I know that, but I want a very, very basic example of a tree.
you want programmatically where it is used.
Like organization charts and file form structure is a tree based. I know, but is that okay?
You see now. You see here. My screen is still visible. Am I still sharing my screen?
Yes, please proceed. Yeah.
Okay. I know.
You have lost your screen.
Yeah. Now you are seeing my screen, right? So you see in your explorer. This is a very classic example of tree, right? You see, there is a species node. Under that, you have many other nodes. You can explain that. I can expand that. This don't have any further folders under it. But if I expand the documents folder, it has some other things under it. I can and I can go further inside. So you can see some hierarchical things here, right? So this is the kind of tree. Like it has some hierarchies. Same way, where else? Simple example where okay, I'll find those things later. Very simple things. When I find, I'll let you know. Only it's not coming out of my mind. Now, Vidya told a lot of things, right? Let's go through those things and then we'll come back to that one. Okay, so she told a lot of things like root, and she told branch, and she told about leaves. Okay, and what else? Parent. What else she
Siblings.
told? Anybody else?
Siblings.
Siblings.
Ancestors.
Vallabh said
Ancestors, and then uptree. These are the terms we heard while Vidya is explaining, right? So let's go one by one. So generally, if you have a tree, what we have in normally tree, if you say it will have the roots, it will have the branches, and it will have some leaves kind of things. So generally, if you take a tree, it looks like this, right? But in our data structure wise, we cannot exactly correlate like this. It will be kind of inverted. So our root will be at the top. We start from the root node. So every, and the important thing, node. Okay. So every element in a tree, we call it a node.
Okay, why is the root at the top? Why can't the root be the bottom? Usually, trees have root at the bottom, right?
That's a good question. Anybody wants to answer? Because I don't know the answer.
No, it's about the perspective. We see actual tree, the root comes from the bottom is our assumption. Like the root is at the bottom, because we don't see the root, we see the top of the tree first, and we say tree is the top of the tree is like at it's not at the front, and the tree root is at the bottom. You can also draw it the other way around and put the root at the bottom and start branching out the children from the down, and it is the same.
Yeah, exactly. Right. You can draw
I
like
think it
this
is
also.
for our convenience how it is easy for us to understand in a better way.
So
Got it.
when we grow like this, generally we start from the top of the paper. We won't. Then it will be good to explain or expand the tree while you're going further, adding branches and other things. It will be easier for us to put it upside down. So there is no particular reason for that. Okay, just for our better understanding, we are inverting it. And yeah, so coming back to this node, every element that we are adding to a tree will be called as node. Okay. And every tree will have a root node. That is, okay, that is a question. Can a tree have more than one root node? Anybody?
why not just one? If you mean one more than a one, or what do you mean?
The first node, the top node, we call it as root node, right? This is, we
Yeah.
call it as root
Hey,
node.
by the way, one question, right? Before we discuss about the connections, what is node? Does everyone have a good understanding of node?
So let's take node. Okay. Let's little deep dive into node. What is node? Okay. What are the things will be present in the node? This will help to write our program. First thing, what are the things present in the node? First thing is our data, right? Obviously, we should store some data. Can be a picture, a file, or anything, a string. Okay, let's say commonly we call it as data. So first thing I gave, data will present in the node. What else will be present in the node?
Address, child address, yeah.
Child
Children.
address means how it will have. Child address means only one.
Children, it will have multiple. It is going to point to another tree, actually.
So we can say it as children, right? What I want to convey here is it's not one element, one address. It's a collection of addresses. Children. Okay. A node will have a data and collection of its children. What else? We're forgetting an important thing. Don't look only root node. Look at this node. So you told data, you told children. What else
Branches.
is there? Okay, this is branches. Okay, branches. Anyway, we can say that the children address only comes as a branch.
Edges, you mean?
Edges, yeah, edges, branches.
Hey, just one question, right? So when we are discussing about node, in linked list also we call it as node. In graph also we call it as node. So what does like common across all the data structures, right? When it comes to being a node.
Node holds data.
Plus node holds the data plus
Plus depends on the data structure that we are talking about. If it's linked list, it will hold the address of the next node.
Okay, then
If it's going to be tree, it is going to be holding the address of the children, and also the address of the root parent.
Parent, yeah.
okay.
Okay.
So
It depends upon what tree that you want to construct, right? If you want to hold the link to the parent, it's up to us.
yeah,
So basically, node
what
is
data structure?
fundamentally something that carries the data along with the connection information to the another node. It carries what? The connection information towards the another node. Yeah. Okay, let's continue. Go ahead, Gopi.
Yeah. So now you guys told that node should have a data, children, it is a collection, and a parent. Okay. Now, if I connect this one here, okay, is it allowed or not? Now this node can have two parents or not in a tree.
Is it vision?
I don't get it. So can you repeat that?
Is it a collision? If it has node having two reference of as a parents, then the search will be collided, huh?
No.
It,
Okay, go ahead.
it's
Go ahead.
not going to be a tree anymore.
That's a good question.
Right.
Hello?
Right. That's not going to be a tree anymore. Yeah. If we connect like this is not going to be a tree anymore because our tree always starts from the root and it branches out. It can have many branches like this. It can grow like this, but it cannot come and join like this unless it is a banyan tree. It will come and join to the root. Okay, but typical tree will have always branches pointing outwards. Okay, so this is not allowed in the tree data structure. When we do this, that becomes another data structure that we'll deal with later. This is called graph when we connect multiple nodes. Okay, there is no such thing called root and leaves there. It is simply nodes and edges. Okay, so let's focus only on tree. So this is not allowed. Okay, multiple parent is not allowed in tree. So keeping this in mind. Okay, okay, another thing. So what are the things we saw now? Node, we are clear, right? Node is what do we say? A data structure which holds data, its children information, its parent information. These are all basically addresses. This is only the data. And node can have two types. One is root node. Oh, sorry, three type of nodes we can see in the tree data structure. One is root, that is the top level node, that is called root. And the bottom nodes, the nodes which don't have any children, those are called leaf nodes. Okay, so we are clear about node, root node, and leaf. And the parent we saw, and the siblings. What we call as siblings? No, the nodes which are at the same level. Suppose
Or we can
this
say
is
the nodes that have the same parent, right?
yeah, right. That is also, yeah, the parent, the same parent, that we call it as levels. Okay, the node which have the same parent are called siblings, and this we call it as the levels. Okay, and the children of these nodes are at the next level, right? So this is level 1, this is level 2, like that it will go. So levels also one important term we need to consider. Okay, so if we know siblings, what is ancestors? Suppose if I take this particular node, what are his ancestors? Ancestor means I have to go upwards, right, until I reach the root node. The ancestor of this particular node is this one and the root node. If a tree is very big, you will get a big list here. Okay, and what is subtree?
Gopi, maybe can you write some letters for those notes? Then we can say it is
Okay,
easy to
yeah,
answer also for discussion purposes.
right. Okay, yeah. So now what is subtree?
BEF, that is a subtree because it's a complete, we can call it a complete tree.
Right. So this is one subtree, right? What else? Every node itself a subtree. Okay, even it is a single node, it is a subtree of this tree, right? Even if it is a single node, we call it as a subtree. Okay, that's very obvious, right? Every node is a subtree of the main tree, and we can say this has one subtree, this has one subtree, like that. We cannot split it, but if it has children, we have to consider it as a single subtree only. Now you understand the terms that involved in the tree data structures. The node is very important. The root is the top level node. The branches are the edges. This is the connecting connection between the two nodes that we call it as branches or edges. Okay, and the leaf nodes are the nodes which don't have any children under it. The parent is the parent of any node that we call it as parent, and siblings, the nodes at the same level are called siblings. Ancestors, how the node is connected to the root node, all those path is called the ancestors. The nodes in that path are called ancestors. And subtree, any nodes or any sub collection of nodes under the tree are called as subtrees. So now we want to, if we want to write this data structure, if we want to make this into action, what we need first? We need first this one, right? We need to have our node that should capable of holding a data, capable of holding its children, capable of having its parent information, right? And Vallabh, for your scenario, the game is there, right? In that, which tree we are using? Like, is it a binary tree or it is a?
No, it's not a binary tree.
Yeah. So let's briefly explain what is a binary tree. So suppose here you see I can add any number of branches to this root node, and the subtree can grow under this one, right? So there is no limit in this one. I can have 3 children over here, and this again can have some 4 children. Like that, we can build a tree. But if you take a binary tree,
If I can ask question, Gopi, a fundamental
yes,
question
yes,
before we begin, because I did
right.
not attend the previous class. So I want to know, I want to have a mapping of which segment in the data structure. Like we have 4 parts, data, heap, stack. So those 4 segments we have. So in which segment this tree is used in all the segments, or it's specifically used in some segments?
Okay, I want people who attended last session to answer this one. If we create
No.
tree data
One second.
structure,
So, yeah. Sorry to interfere. So, Vaishnavi, why don't you answer your own question, right? Think about, like maybe think through that while somebody else attempts to answer. But I would say the answer exists in your question itself, right? Okay, continue. Yeah, whoever has attended last week's session, try to answer.
yeah,
Balamurugan or somebody.
where this data structure would reside. If you create these nodes, where it will go and well, last time when I explained linked list, I told that why we went for linked list from array, right? So that part we covered, right? Array is like continuous memory, and that has some drawbacks. What happened? No answers from anybody.
Sorry, what was the question again? I was waiting for someone to.
Vallabh,
Yeah.
another question. When we create a tree data structure, where these nodes will reside, either in code memory, data memory, heap memory, stack memory.
It's going to stay in heap.
Right.
And why?
Right. Why?
If we are creating this
Why
thing,
not in stack? Why not in data?
no, that's the thing. If we are creating this thing inside a function, then it will stay in a stack. And if it's created if it's standard coded values, if it's not dynamic, it's going to be in code memory.
If you put this in a stack, okay, if we put this in a stack, let's assume we are going to put this graph in a stack. Okay, how we'll save this? Generally, stack we will take the continuous memories. Next to memories we will take. I will put a root node here, one here, and I need to save the address of this things
Yeah, we will assume that it's all there in that block.
in that one block. Okay, so then that information, this will point to the next node. So I will point to this one here. So this is 2, and this again has the information of this one, again 3. Okay, if it is in stack, it will be like this, right? And node 4. Suppose I don't have the node. I didn't add the node. Okay, I added some nodes here. Okay, so up to 6 it came. 6 and 7 it added, and then 8 and 9 on here. So okay, let's say I added 18 and 19 here. Okay, it has 18 and 19 here. Now I am going to add a few more after some time. I'm inserting some nodes here, 11 and 12 here. Okay. Now what would happen here? I will come and add 11 and 12 here, and then I delete this 2 things, and these 2 becomes empty. We will clear off these things, but the 11 and 12 will stay after it. The entire RAM will be blocked. Like, if we keep doing these things, there will be empty spaces in between that cannot be utilized by the program very efficiently. Because when we do add and delete, the memory will keep. Suppose if I delete this one, who is going to come and occupy this memory? Nobody is going to come and occupy, right? So this will stay as it is. And it's going to be very difficult to rearrange these things if we try to optimize the memory. So it's not going to be easy or optimized way of handling the things. But if you put these things in the heap, we will look for a memory block which is suitable to put this one node, and we'll take that and we'll point to this. We'll add that address to the 2. So, and when we delete this node, we'll just release that memory. So heap can handle that very well. Like it's not continuous memory. It's a pool of memory we can take, use. After usage, we can release it. Balu, anything you want to add here?
Gopi, you said in the last point, you said we can reuse, is it?
If it is in heap, once the memory is released, that can be utilized by the program when you try to allocate. Suppose it takes some 8 bytes, you say, it says it takes some 8 bytes. 8 bytes of memory it is taking, let's assume. Now I released it. So this 8 byte is come on.
There is some ghost in your computer.
Yeah, I'm writing here and it is okay. Now it's okay. Suppose it takes 8 byte and I released it. So this 8 byte is now available, but now the program needs this 8 byte for some other purpose. I want to allocate 2 integer pointer. Then it will take these 2, these 8 blocks, 4, 4, and allocate that into a int pointer. It will. The heap memory can be utilized like that, but not the stack memory. It is like a pool of memory wherever the chunk is available. Suppose you need a chunk of 4 bytes. If it sees a chunk, then it will allocate it. Okay, but in stack, it has to go, even though we cleared these memories in between, it won't allocate here. It will go to the end and then it will allocate there only.
Okay. All right.
Yeah, so now, yeah, we are talking about the binary tree, right? What is binary tree? The rule for the binary tree is instead of children, node will have just 2 things, left and right. The word binary itself says, right, 2. That means it can have only 2 children. Okay, so the node, you see now the node structure is changing now. For a linked list, our node has data and the next pointer, right? Data and the next. For a linked list, we have. And for tree, what we saw, data, children, and parent we saw. Now, if we take a binary tree, the same node structure changes into data, left, right, and parent information, right? So like this only, the word remains the same, but depends on the data structure, its content is changing. Okay. Now let's go to the program. Vallabh, you can take over. So now basically first we want to create this node. That means a class which can hold these informations. That is what Vallabh is trying to do first. Who is sharing screen that time? Vidya, you are right.
Yeah.
Yeah, please go ahead and share and now start writing that, and it will be easy to correlate now what we are doing. Hope it will be. Any doubts for the freshers? I mean, Balamurugan, Pranesh.
No, not able.
Okay, then
Not
let's
right
go.
now.
And
கோடிங் பண்ணும்போது ஏதாவது இப்போ வந்துச்சுன்னா
okay, Ben.
Messi, how about you? Have you been introduced to this memory concept before?
Sorry?
The stack heap. Are you able to understand this? Do you have any doubts?
No, I got it.
Yeah, okay, cool.
Thank you.
Okay, good then. Vidya, you can share your screen and start coding that.
Okay.
So I'll just show what the game what I was expecting. Sorry, I was on mute. I'll just show the mind map of what game I was expecting, and we can then go to the code. It will be very short. 1 second. So this is the tree that we are going to code. It's going to be the classification of animals. It's going to be land animals, amphibious animals, and aquatic animal. And there are other types like birds, insects, and germs. So we will have them all loaded up. For the classic case, we will have everything stored already. And for example, if I'm showing you a lion, and that will be coded as carnivorous mammal, land animal, and we can have the ancestors as questions. Is the lion a carnivorous animal? Yes or no? And if you click yes, it's going to traverse through the tree and find the lion and check the ancestor and say yes, it is a carnivorous animal. What you said is right. This is the functionality of the game that we are expecting to do. Is this clear? Guys?
Vallabh, Vinodara explained. Can you explain it again? I missed it.
Sure. Okay. So we have this classification of living beings here.
Mhm.
We have land animals, amphibious, aquatic animals, birds, insects, and germs.
Mm.
And land animals is classified between mammals and non-mammals.
Okay.
Inside mammals, you will be having herbivorous, carnivorous, and omnivorous. And for example, I am saying lion. Lion is a land animal, a mammal, and it's a carnivorous.
Okay.
So this tree will be having a animal called lion, tiger,
Okay.
etc. So if you show a picture of lion,
Mhm.
and you can ask the question about its ancestors. If it's a lion, is it a carnivorous animal? You have to traverse through these trees and find the lion and check if it's carnivorous or not, and then show to the user that yes, you have selected carnivorous correctly.
Okay. Okay.
Is it a mammal or not? So on so forth. We can ask the question about its ancestors, and we can further develop the game. We can give more data about the lion as its children nodes. Like lion can give 4 cubs. Lion can eat 10 kgs of meat per day. These data can also be added to the as a children of lion. So we can also ask that question. For now, it is only
Okay.
simply the
Basically,
ancestors.
we give the animal information based on its parent, and the children will have the information about that animal. The
Yes.
parent is basically its the carnivorous or mammals or animal. Those information it will have, and the children will have its features like how much it eats, how fast it can run, properties of lion kind of thing, right?
Yes.
Given an animal, we can ask a question and it will traverse the tree up and down and it will tell appropriate answer,
Yes.
right?
Yes.
Okay. So you are explaining this thing, right? Have you guys heard of embeddings in the embedding means in context AI? This generative AI models are there, right? Anybody aware of generative AI models?
ChatGPT.
ChatGPT, yeah, ChatGPT are there, right? So in ChatGPT, there is one concept called embeddings. Okay, this is very similar to that embeddings. Maybe at the end of that session, I will say how it works. Or you guys heard of? I'll explain that embedding and vector search. These two concepts. The search, how the search can be so faster, and that thing I'll explain at the end of session. Just 5 minutes. I'll just give a brief. Go ahead, Olu.
Yeah, that's it. I've explained the game. Now let's start to create our database. It's a tree.
Okay. So now Vallabh explained the game, right? So we have our node. We have to create our node. So in the node, what information we are going to store? Data. I am asking just the data. What data we are going to store? Anybody? It's just
Like string, array, or a string.
a string. Basically, information of a particular thing. Yeah, it's a string. Is it everybody okay with that? Our data is going to be a string. Everybody okay with that? Any other things we want, or just string is enough?
Vallabh initially said, or you, I think you also said that, Gopi, if we show a, what is it, a picture of of a lion, then it should actually traverse through the nodes, and it has to then identify that it's a carnivore, right?
No, the picture.
Vallabh, yeah.
We also discussed the picture as the input or not.
Yeah, but we can have the picture as an extra information. We don't need
Okay.
to search using
Okay,
the
okay.
picture. For the first
Okay,
iteration of the game, it's not required, I think.
right. For simplicity, let's say our data is going to be just the string. Okay.
Right. Yeah.
And if it is a string, we can store any information. Right. It doesn't matter what information, like what kind of mammals or non-mammals, land, amphibious, anything we can put there. So let's take our data is going to be a string type. Okay. And what we have to put in the parent. We saw a node should have a data, node should have a parent, node should have a children information. In the parent, what we will store?
Okay, for the are you asking about the root node, or we can go specifically with the node name?
Any node, if it has a parent, what you will put there? What is the data type of that parent is going to be? So you told data is of type string, right? What is the type of that parent?
Parent is going to be a root. Sorry, tree.
Tree, yeah.
Yes.
Why we need a tree there?
Because the parent is going to hold children's, and also the address of its parent.
No, if I take a single node, I just want to know what is my immediate parent, right? I don't want the entire tree there, right?
No, it doesn't matter if it's an entire tree or just one parent and two children's below. It is a subtree, right?
Okay. Last week we saw that linked list, right? In the linked list, we created a structure which holds the data of type integer, and we created the next variable, right? What data type we gave for that next data type?
New.
That is to create data type. I'm asking data type. Integer, pointer, some pointer. Okay. So we saw everything is a node, right?
Yeah.
Root is also a node. Leaf is also a node. In between nodes also, everything is a node.
Yes.
So your parent is also a node, right?
Yes.
For a given node, a parent is also a node. So you want to keep the information of that node. So what do you need to keep? The address of that node, right?
Yes.
So in what variable you can store the address of a node?
In a pointer variable.
Right. What pointer?
It's going
pointer
to pointer to a string pointer.
No. The same mistake you did last time also, Vallabh. Yeah. We should not keep. You have to address that entire node, right? Then your pointer type also should be node. Then only
Yeah.
you can.
So just one question, right, Gopi? Just one question. Just for everyone to get a clear picture, right? What is the data type?
Data type.
Yeah, data type.
The type of the data, whether it is just numbers, mix of characters or numbers, or just or a list of any given.
Correct.
Those are
So data exists in different forms. So and data can be a number, can be a character, right? A floating point number or an integer or a string. So different data exist, right? So what does the type infer? If I say something is u int 64 underscore t, What does that infer?
Unsigned integer of 64-bit.
Yeah, but what does it infer? That
If
is
you give that
direct.
one, if you give
See,
that
if
one,
you
what the
say U in
compiler will
64,
do?
you know it is unsigned integer 64-bit. But what does it infer? What does it indirectly tell us?
It is
It is for the decision of the compiler what to do.
No, it also
Okay,
gives an
compiler is
idea
going to do
about
what?
what the
Compiler is going to do what?
It's going to do the
operations.
correct operation. If it is a string, it's a different operation. If it's a integer, it's a different operation.
Okay.
You know,
First thing is
there can be
compiler
few
will
things.
identify the right operations. Right? If
Yeah.
it is an addition operation, it will use add instruction for adding
Yeah.
64-bit number instead of 32-bit number. Okay, identifying the right instruction based on the data type. Okay. And then
Yeah.
what else? What else?
The amount of memory allocated.
Exactly. The
That is the
size,
important
right? The
point.
size or amount of memory. That is a very important thing. So U in 64, how many bytes?
64.
Fantastic. 64 bits means 8 bytes.
Right. Yeah.
Right. So now coming back to question that Gopi asked, right? So what is your node? Your node is a
Address.
data. No. Your node is actually some data,
Okay.
isn't it?
Yeah. It has
Which
to
And
be.
the
contains multiple
type of the
informations.
data, yeah, and the type of the data is data type, right? So what are all the information that exist in a node?
I have a data and address of my parent and address of my children's.
Great. So basically, you have some data plus you have address information pointing to another node. Whether it is one address or multiple address, we don't know. Right? We may call it as parent, we may call it as children or array of children, or we may call it as next node. It doesn't matter. Basically, number of pointers. And each pointer, depending upon the machine, is going to take 8 bytes. Right? So some data plus pointers. So
Okay,
now
let me take the
this,
screen again. I will quickly explain what Krishnabalan is saying in a little bit. You see my screen
okay.
again?
Yes.
Okay, so let's say we
We
already
lost the
know
question.
that.
Gopi, I actually lost what's your initial question.
Okay, what's my initial question is, we are creating a node, right? Node is going to have a data. I want what is the data type of the data. So I create a variable called data and I want what type it is. So everybody concluded that it is going to be a string, right? So we create a structure called node. Under that, we are creating a variable called data of type string. And we want to create another variable called parent. Okay. So now we are discussing what should be the type of this parent. What should be the type of this parent? So for that, what we are having, we have our root node, we have our children. Now any node if I take, it's going to have a data, it's going to have information about its parent. Suppose 2 is my node, I should hold the information about the root node, I mean the parent node. It can be root node or any other node. Okay, just the parent information. So I should know who is my parent, right? So that means I should have the address of this node. So for that we had a confusion like okay, our discussion went that way. What is the data type we are discussing, right? when we went to what is data type. So when we say int a, what compiler infers from it, it knows that I need to allocate a 4-byte of memory to store the value that are given in a. For a variable a, I need to allocate 4 bytes of memory. So that is the thing compiler is going to infer from it. Suppose if I say char, then it infers I'm going to allocate how many bytes for char? Anybody? For character, how many bytes?
1 byte, 1 byte.
Okay, 1 byte it's going to allocate. So like that, the compiler will decide. So if it is a pointer, for example, I say int star b, then what compiler will infer from it? So any pointer means address, right? Pointer means address. So this variable is going to point to a address where the 4-byte is allocated. So int pointer means int pointer b means it points to the first address of that 4 bytes. So we have 4 bytes, right? First starting address of this 4 bytes will be allocated. Okay. So now similarly for character means character star something is there. Yes, C is there means it's going to point to the memory where the 2 byte is allocated. Okay. Similarly, if we create a node, our node, for example, last time we saw linked list node, right? That has only data and next. Next is a pointer. Okay. So in order to allocate memory, what compiler would do for this? For example, we say integer is the data and there will be address. We need to store the address, right? For star. Okay. So what compiler would infer from this is in order to store this entire thing, it has to allocate integer and another 4-byte to store the address of the memory where another complete node will be. So this is the node. So here 4-byte will be there, here 4-byte will be there, and this 4-byte holds the address of another node where 4-byte is for data, another 4-byte for us. Okay, so like this, compiler should know how much memory I need to allocate for this particular object.
Gopi,
Hmm.
can you reshare your screen? I've lost your
So
screen.
it stopped. Huh? Okay, let me reshare it. Yeah, is it visible now? Visible. Sharing the right screen. Rita? Yeah. Okay, I assume it is visible. Okay, what I'm saying is, for a node, we are creating a structure or a class of one type, right? That we call it as a data type. So integer is the data type, character is the data type, right? Same way, whatever the class, whatever the structure we are creating are called a data type, user defined data type kind of thing. Okay. So I can create variables using this class or a structure. So I can say node A, node B, node C, like that, right? So for every node A, node B, compiler has to allocate the memory. So how it will do the allocation? It will first go through the properties present in that data type. So we have, what are the informations we have? Integer and then address. So for integer, it will allocate 4 bytes. For address, it will allocate another 4 byte. But address is always going to be 4 bytes, but it should know another information. What address it's going to point. So what address means what data type it is going to point. We need to give that information. Then only it can identify that entire chunk. Otherwise, it don't know when to stop. If we simply say address, it don't know whether I need to read 2 byte or 4 byte or 8 byte. For a node here, we say it needs 8 byte, right? And how it knows it needs 8 byte? We have to tell my address is of type node. Then only it know I need to read 8 bytes. Otherwise, it may read a 2 byte, it may read a 4 byte, we don't know, right? So in order to tell the compiler how many address, if you give an address, how many bytes from that address I should read. That depends on this data type we are giving here before the pointer. But pointer is going to take 4 bytes only. From that pointing address, how many bytes it has to read, that is decided by this data type. Okay? Is that clear? Okay, so why this question came is, now coming to our initial question, what is the data type of the parent? I almost gave the answer. Now, anybody? What is the data type of parent? Node. Just node.
Node star.
Node point, because we are not going to store the entire node. We are just going to store the starting address of the node. So we say, we always mark it as a pointer. Okay. What is the next one we want? Children, right?
I have one doubt.
Hmm.
If you don't put a pointer there like that star, so does it makes a copy? Like
Yes, it will make a copy and it will allocate that entire memory required for it. Instead of just 4 bytes, if you don't put the star, it will
Gopi,
look
once again,
and
right? Gopi, can you write down without the star and let's dive deep on that, right? I want to double down on that particular question.
okay. I'll write again here node as string. I just put str and data, and I have node without star, and I
Without star.
have
So is that possible?
yeah, that's yeah,
See,
right. Good question.
what is the data type infers, right? So the data type tells the compiler that how many bytes of memory is needed to save the data, right? So a data type tells what? How many bytes are needed to save the data. That is what a data type does. The first important thing that it does. The second important thing is the meaning of it. Hey, should I infer that as an integer or a floating point number or array of characters? That is the next thing, like the semantic meaning, right? So the first information that it gives is how many bytes does the data need? So the question is, when you have a node star, when you say it's a pointer, how many number of bytes does the pointer need? Whether it's a pointer to an integer, whether it's a pointer to a node, or whether it's a pointer to anything, right? How many bytes does a pointer need?
depending upon the compiler, if it's a 32-bit addressing compiler, then it will have 32-bit pointer. Always.
Right, right? A 32-bit number, right? Because a pointer is what? An address, right? If the address width is 32-bit, then you need a 32-bit number because the address is nothing but a 32-bit number, right? If the address is 64-bit, then what we need? It is a 64-bit number. So we need 8 bytes, right? So given a compiler or given a platform, when I say platform, given a processor, right? We know for sure the size of a pointer, whether it is 8 byte or 4 bytes. So pretty much you can do pointer to anything easily because you know for sure the size of the pointer. So here the compiler knows what is the total size of the node, even if it includes a node star pointer, because node star means what? It is a pointer. How many bytes it requires?
Pointer always, like, let's assume it is 32-bit and it says 4
4 bytes, right? In this case, 4 bytes, right? And your string is going to take that's another different topic. But let's assume if you
Yeah,
just
that's
have an
why it's
integer, then another 4 bytes maybe, right? So you know for sure the size at the time of creating the structure, right? So here let's take the other structure where we removed the pointer. So what is the size of this structure?
for
What is
integer
the
4
size of
bytes.
this?
And
What is
would be
the size of this data type, right?
Sorry, what is the size of which
So-
data type? Node pointer.
The second one,
node.
Gopi, can you make it with a different color or something? Yeah, just mark round it with some different color so that people can understand what we're talking.
We are talking about this
Yeah,
one.
this node, right? What is the size of this?
This node has data of integer data and a node parent pointer. So
No, that's not a pointer. That's the fundamental question. If you have a pointer, you know for sure.
Okay.
You can clearly add another 4 bytes. The question that Shivam is asking, right? Hey, this is not a. If it is not a pointer, then will it have the content as a copy? That's a question from Shivam. So my question is that even the structure possible? Because now, because the moment I'm saying it is a structure or a data type, the compiler should know the size of the type. Otherwise, the compiler is not going to allow you to compile, right? So now in this node, which has no int data, then node parent, is that even possible?
Let's write down what would happen now. So we know the size is allocated like this, right? Int data, 4 bytes I allocated. For node, how many bytes? It will go again inside node and it will see I have to allocate 4 bytes, right? For this thing. So when I create an object of this node, first it's a enter here and it will try to calculate how many bytes is required. So it sees the int and it allocates 4. Then it sees the node and the node is of type this one, right? Again, it will go inside and see for parent how many I need to allocate. For parent, I should allocate first 4 bytes. Again, it will say 4 bytes. Then parent would have again the node, right? And it sees the node there and it goes inside again and it repeats, right?
Till there is a
Yeah. So
overflow.
Basically, you cannot define the size of the structure at all. So such a structure is not possible at all. If the compiler does not know the size, this structure is not possible.
Can you repeat
Is
the
it
question?
indefinite? It's looping over and over, and then we cannot say the limit. It's indefinite.
No. Imagine Vaishnavi. The compiler itself is another program, right? compiler itself is another program. Somebody would have written a tree parsing inside the program. The compiler uses abstract syntax tree. Basically, whatever tree that you are learning, there is a glorified way of using a tree called abstract syntax tree. So basically, a compiler parses all your content into a tree, and then it traverses through the tree to create your machine code. Right? So what I am saying is, whoever has written the compiler, they would be parsing through the structure to understand what is the size. And they know it cannot be parsed. Because it is pointing to what? The node itself. Right? And they cannot understand the size of the node. It's called self-referential structure, right? This is not able to, it cannot understand its own size. So the compiler will throw an error saying that, hey, you cannot point to the same structure. Maybe if you want, you can actually write this code and then see by yourself in C++. But this is not possible because the compiler does not know the size at the compilation time. But the above structure is possible. Why the above structure is possible, which has a pointer?
Because for a pointer,
The size is
we
known.
learned that is always going to be fixed address, like fixed size. For any pointer, the size is going to be 4 byte. If it is a 32-bit machine, or 8 bytes if it is going to be a 64-bit machine. And
Yeah, this is like
pointer
very,
is
very, very
going to
important information. Because lot of
this
things
pointer
happen,
going to
right,
point
in
to a chunk
programming
of
world.
that memory.
Yeah, it's through these pointers. Everything is fundamentally a pointer. That's why we learned address for like so many sessions. We learned address is just a number, right? Hexadecimal number that we saw, 64-bit number or a 32-bit number. Why did we learn address for so many sessions? Is because at the end of the day, it is all going to be this address.
Right.
So even your stack
now,
memory, heap memory, or your data memory, or your code memory, all these things that you see, anything that deals with memory, it is just an address and there is some content. Why we give all these different names is because of the life cycle of the memory that we will dive deep later as well. Okay, but for now you can get a picture of it. Okay, go ahead, Gopi. Sorry.
yeah. So now coming back to our original thing, we are designing this node, right? So node is going to have a string data, node star parent. So now what is the other one we saw? Children, right? So for children, what is the data type? Anybody? Based on our discussions now, what is going to be the data type of children? We know children is a collection of what? A collection of what?
Collection of addresses.
Collection. Okay, collection of addresses. Yeah, right. But we can say it as collection of nodes, right? Yeah, collection of addresses. Nodes addresses. What would be the type then?
Node only, node star. Asterisk.
If I put node star, what would happen? I can point to only
Only one.
only one, right?
So we
Then
can
what
put
should I put?
two asterisks for
Two
multiple.
asterisks. Yeah, that is we can do two asterisks and then it points to an address. There is another simple thing also, right?
So basically, it will become an array of addresses.
Array of addresses. Yeah, we can use array of addresses. That's up to us only. We can use a double pointer or we can use a array of addresses, right? What is the syntax, Balu, for C++? I forgot. Array of node we'll put like
No,
this.
array of pointers, right? Just
Put
a pointer and then put a array subscript at the end. That's it.
at the end. Okay.
Okay.
Yeah, put a star in front of it. Yeah, and then subscript
Right,
at the end.
and
That's it.
then this one.
Array of
So
pointers.
it is an array of pointers. So our class or the structure, what we are going to create should have these informations in it first. Okay, so now we are writing in Python, right? Python may not have these syntax, but in Python, all the classes are already pointers. It's going to store it as a reference only. So no problem. We can, this extra syntaxes and all not required there. In C++, we need this syntax. A better understanding, it gives better understanding. We are pointing to an address. We have the clearly, this code is clearly explaining that we are pointing to an address. If you see the C++ code, but in Python, it is not explicit, but implicitly it is doing that one. It is pointing to an address one. Okay. I think we are already running out of time. Already ran out of time. Sorry. Yeah, but it is a good discussion only, right? Can we create that class alone and wrap up today's session? Okay for everybody? Is it okay for everybody?
Yeah, I think we should create the class. Let's create the class and
Right,
then
right. Let's create the
we can
class.
continue
I'm
next
stopping.
week. Yeah.
Yeah. Vidya, sorry, we interrupted you a lot, and you can share now and write that code.
No, that's all right. It's needed, right? To
Hey, no,
to
you
have a
didn't
good
interrupt, man.
understanding
You
before we
steal the
keep
show,
going.
man.
Yeah, right.
Okay, go ahead with your நீங்க அந்த class
Okay, go
மட்டும்
ahead.
நீங்க I can create it, I believe.
You guys see my screen?
Yes. And zoom in a little so we can see a lot of your code. I think control scroll will work. Control plus scroll.
Control plus plus. Hit control plus plus.
இதுதான் பண்றேன்.
Okay.
I think there is something with the internet. There is a delay.
Okay.
I think
It's
so.
better now. It's better now.
Yeah. Okay. So
So let's not create that methods first. Okay, it's already there. Okay, value is there, children is there.
mhm.
What is
Yeah,
other
Vidya, you can explain what you have written. Yeah.
That's VS Code.
Explain how it would solve the problem, right? You are missing parent, right? So you can add that as well, explaining everybody.
I do not know if my explanation is going to make things clear or cause more confusion.
Yeah, that's okay.
Either way, it's
You
good.
can
Either
just
way, it's
explain the
good.
first part, that class you defined, right? And then what are the things you
Okay,
are
so we want to actually create.
Let's not jump into that methods first. The node, the content of the node we saw, right? These are all. So any class will have properties and methods, right? The properties are like the data it is going to hold within it, and the functions are like the operations that is going to perform with those data. So let's focus on the data side only first, and then we'll add the functions or the methods. So for now, the class, the line number 5 and 6 you added, right? Value and children.
Mhm.
So value is what? Value is our data.
What the node is going to hold.
Yes, what the node is going to hold, that according to us, it's going to hold the string informations, right?
Mhm.
Yeah, but by the way, one fundamental question, right? Like, let's start from line number 3.
Yes.
Okay, that's the starting of the class, right?
Yeah, right. I
Mhm.
missed that.
What is this class?
So we are saying that we want to create a tree which is an object. So
Oh,
it
okay.
has
So
a lot of
this is where we need to be
properties.
very clear, right? Is this the tree
Mhm.
or is this what?
This is not a
Root.
tree. No, this is not a root also.
Is this?
This is
What is
trying
this
to
class all about? What does this class contain, right? So basically we can name a class based on what it contains, isn't it? So what it contains a value, it contains array of children, and it contains a parent. So what is this
I think it should be node, not tree.
node of a tree? So then how can you
Yeah.
name this?
Node.
Okay. So you don't need to put this node of a tree, right? You can put in
No,
camel
no, no.
case
Just
tree
just
node.
for
Tree
this
node.
is not the final code yet, right? So because everyone is seeing the screen, just for clarification purposes, we of course we can modify it.
Yeah. So basically in Python, if you follow the Python coding conventions, camel case is what they use. So either you can name it
Yes.
as node of a tree or you can call it as tree node. Usually called as tree node. Okay, great. So now everyone is clear that this object is creating a tree node.
but this is not an object currently. It is just a class, and we can create an object later.
Right. Right. Yeah. What Balu is saying is this is the class which is going to hold the information about the node.
This is just holding the template. So now we can create objects based on this class.
Right. Yeah. So we added two informations already: value and children. What is the missing information?
Parent.
Parent. Yeah. Let's add that as well. Line number 4 is there, right? That is kind of the constructor kind of thing, right? We'll pass the informations. So while creating, so we need to pass the other informations, or we can set later also. Okay, first parent. Okay, we are passing the value and setting that value, and children is empty, parent is empty. Okay, make it empty only, parent empty only. Don't take it as an input or something. Just take it. And,
For now,
should
we
be
should say no, right?
yeah. So when we create a new object, now we have to pass the value to the object, but the children and the parent we can set later. So how we can set the children and parent? The add parent method, add child method, right?
Yeah.
So add parent, what it does, I think you should turn off your Copilot. It's adding the code by itself. It's not letting us to think.
It normally turns it off with this shortcut, but it's not working now.
Just click on that. Is it not? Okay, it comes this way.
Yeah.
Disable completions. That one. Disable completion.
Yeah.
Okay, right. So now, I can set the parent of the node using the add parent method. I can add children using the add child method, right? So
Yeah.
if you look into that add parent, what it is doing, what that method is doing, can you explain that?
We are actually creating a parent node.
Just adding a parent.
Yeah, we are adding the
passing in a parent and setting the parent to this node.
Yes.
And what does the add child does?
This same as parent, so except we are doing it for the child here.
And the difference is the children is array
Added
here.
to the
So we are
parent.
doing an append.
Yeah.
We are doing an append here, right? There can be many children. That's
Yes.
the reason we are doing that append here. And what else we need? Suppose I want to delete a node, delete a children, delete a child. So what should I do? Remove child or delete child. One method should be there, right?
No, you don't need delete. Oh, you need a delete child, and also you also need delete node.
Delete parent, you mean?
No, node.
That we have to do outside this class, right? For example, you created a tree, and you want to remove from that tree means what you will do, you will disconnect that node and you need to find that node and go to its parent. From the parent children, you need to remove them. So
Okay.
there is no delete child
Delete
separately.
node.
I mean, delete node
What if I
separately.
want to
You have to
delete
go
the
to the
whole
parent
subtree?
and remove from that thing, right?
No, what if I want to delete the whole subtree?
Yeah,
It's still
whole
the same way. Okay,
subtree,
go to the parent and delete the child.
right. And if you want to handle you can simply disconnect, but if you want to handle the memory and all, you need to go to the leaf node. From there, you have to come up and release all the memories, all those things in C++. But Python, we no need to worry about those things.
Mm.
Okay, so is this enough for a node? Anything else we are missing for a node class? Is it good to add the information that we Vallabh showed? Like I have amphibious, I have a land animal, I have aquatic animal. That information and then to that nodes I want to add further information. So for all the scenarios, this node class is sufficient or not?
Yeah.
Yeah, I think it's sufficient. Okay. If anything needed, we can add later also. Okay. So far, good. And
We can create an object, one object, and then we can wrap up.
yeah, let's try that. How we do that? Python experts.
Tree node space. I think it's the same, just like C++ here. Tree node space animals. I think so. I'm not
Let's
an
say,
expert here.
let's say aquatic. That node will create aquatic animals. How we'll create aquatic animal
No,
with this node?
first we need the root node, living.
Oh, okay, you want to create the root node. Okay, living things.
Tree node.
We need, then that will also be another class, right?
No, that is an object. Object of tree node class.
Let's create a node. That diagram we saw, right? The root node of that entire tree is the living things. Under
Yeah.
living things, we have subcategories. So we are going to create a root node called living things. How will create that node?
It's going to be tree node space.
Then that will be a function, right?
No. Don't create. Just it is inside the main method or something.
Yeah.
Tree node space.
Living.
Let's say living things. When you create a variable, start with small letter. L small letter. That is fine. Tree node is L small letter. Living equal to what is the how is the syntax for creating an object in Python? Do we need to add new? All right.
I'm not sure here. Any other Python experts, guys?
Just create a tree node brackets and pass in the value. Tree node. Let's say tree node.
Okay. Just tree node. Don't give the equal to. Go back. And bracket. Open bracket. Our value is string, right? You can just put a double quotes and enter living. Double quotes.
No, I think there is something with the internet. I don't hear anything.
Oh, okay. How about now? Double quotes living. Root equal to
Somebody is typing. Who's the
tree node of living. Yeah, copy paste this if you're hearing.
Okay, tree node of living. Without new keyword, we have to use that one. Okay, no need to put tree node at the.
Yeah, I don't think she's able to hear us.
Okay. Yeah. So now we know we have our class. Let's take this as an assignment because it's already half an hour we passed. Let's take this as an assignment, and we will try to create the complete node structure. The traversal part we will do next class. While coming to the next class, it would be good if everybody have a solution to create that node. Complete node. Sorry, complete tree from the living till some animals, like in carnivorous few animals as a leaf, and in amphibious some animals like that. Sorry, herbivorous, carnivorous, herbivorous like that.
Okay. And Vidya,
Take that as an assumption.
she's still not able to hear us, I think. So it's okay. I'll ask her to push this code into Git, so
Right.
everyone can start from this point. But I recommend everyone to start from the scratch and do it, so you get familiar with coding.
Yes.
And if possible, write a few
You guys
sentences.
hear me? Hello?
Hello?
Yes, Vidya.
Oh, okay. Okay, now I just disconnected, joined back. I think the screen
Yeah,
sharing also
what
stopped.
we are discussing is we are asking everybody to make this as an assignment. And
Okay.
while coming to next class, we want everybody to ready with their code. That means creation of the tree, up to creation of the tree. No need to, but if you have time, you can implement the traversal part also. You understand the overall game, right? So if you are interested and if you have time, you can do the traversal part also. Otherwise, just up to creation of the node, tree, if everybody would finish before coming to the next class, it would be good. We'll save some time. Okay.
Okay.
Yeah, then we'll wind up for today. Thank you everyone. Krishna Balan already left. Huh?
Yeah.
Thanks, everyone.
Yeah. Thank you.
Bye-bye.
Everyone. Bye bye.
Nice evening. Bye bye. See you next week.